Good evening, everyone. I'm Dr. Cheryl Holder. I'm co-founder and executive director of Florida Clinicians for Climate Action. Thank you for joining us in our second in the series of Heat and Health for more in Central Florida, but pretty much all over Florida. This program is funded by the generous donation from the Allegheny Franciscan Foundation, and we are here to educate as many people as possible, especially clinicians, on the health harms of climate change, especially heat. So for tonight, we have our meteorologist, Nkose Moose. He's with the University of Miami. He's on his way to getting his PhD. As a matter of fact, he's going to defend in 2 weeks or so. Mr. Nico Simius, Environmental Science and Policy, PhD candidate, University of Miami, Rosenstiel School for Marine, Atmospheric and Earth Sciences. And he's a trained meteorologist, a Bachelor of Meteorology from UNC Charlotte, Master of Geoscience and Climate Policy from Georgia State University. He's very interested in ensuring that our cities are equitably prepared for the implications of climate change, with a particular focus on extreme heat. And thank you, Nkosi. As we said, I'm Dr. Cheryl Holder, co-founder, executive director for Florida Clinicians for Climate Action. We've been around since 2018, and we have done many work in Miami-Dade County, and we're extending our work in Central Florida now and eventually onto the West Coast, and all through to have folks understand the implications. And tonight's session, Nkosi will start and giving us an idea of what climate and what weather and why we call it climate change and what you have to understand. And then I'll come on and give you a brief summary of the many ways that this can happen. This is just a teaser for you to understand how much impact we're experiencing now and in the future, and then join us for the rest of the year every month for another series where we dissect each of these topics in more depth. So thank you for joining. Remember the Q&A, remember to send your feedback and your CEUs. So with that, Nkosi, you're on. Thank you.
One thing that I really want to parse out and make sure everybody also understands is that global warming and climate change are actually two completely different things. We hear them interchangeably a lot. We hear about climate change, we hear about global warming, but one thing I want everybody to understand is that global warming is actually what is causing climate change. Starting off, let's just go back to 1 million years ago and think about carbon dioxide, which is a gas that we have in the atmosphere. It's naturally occurring, but it's also a significant gas I don't want us to think about because it is the primary greenhouse gas that humans emit from our cars, from our homes when we use heat, natural gas, things of that sort, from airplanes. All the human activity is producing large amounts of carbon dioxide. But for the past 1 million years, if you can see my mouse, I'm over here at 800,000 years ago. You see that the carbon dioxide was relatively high. And then up until about 50 years ago, 70 years ago, we had this natural oscillation of CO2 going up and down about every 100,000 years or so. And in the times where CO2 was high, like for example here, that was because we were in what's called an interglacial period, meaning the temperatures were high enough so that the Earth essentially was not in an ice age. So all of the ice was melting. It let go of a lot of the gases into the atmosphere. So the CO2 increased. The concentration of CO2 in the air that we breathe increased. But then when the ice age came around, which happens about every 100,000 years or so, all of that gas that was in the air gets frozen in the ice caps. And when that happened, we would see a decrease. So these low levels of CO2, that's what that would correlate to. So we had this natural oscillation of CO2 for the past 1 million years. Every 100,000 years or so, we go up and then down, up and then down. But now we're at this level and it's really beyond this. The more that carbon dioxide goes up, the more that temperature goes up. And you also may be wondering, if you look on the left side, you see the temperature, the increase that we've seen. And then on the right side, you see in parts per million. So essentially what that means is for every million particles of the air, we have about 410 parts per million. 410 particles of that air are actually carbon dioxide. So it doesn't seem like a lot, but in the grand scheme of things, it's what's causing the Earth to get warmer. Now, the greenhouse effect is not a bad thing. We're supposed to have the greenhouse effect. In fact, it's actually what prevents us from freezing to death because the atmosphere has these gases in it. It traps some of the heat and it keeps us warm. But the problem is the greenhouse effect is now on steroids, meaning we've put all of these additional gases into the air, the CO2, the methane, the nitrous oxide, and they're actually more greenhouse gases. Those gases are trapping more heat. Now, this is important because it modifies something called the jet stream. But the issue is the jet stream is usually very stable. It exists miles and miles above us in the atmosphere. And it's becoming unstable because what it does is essentially serve as a barrier between temperature. So on the north side of the jet stream, essentially here where you see the ice caps, the snow, and then the south side of the jet stream down here in the United States, it's separating that Arctic air from that warm air down below. So it's essentially is like a temperature barrier. We have a jet stream that allows the cold air to be pushed up, further up into the atmosphere, and then that warm air from the tropics is able to funnel itself all the way up into the United States. That's where we start dealing with these kind of extreme heat events. So what you see here is a visualization of the jet stream really across the entire planet. Overall, we're seeing that there's an observed temperature change increase for the most part across the United States. So everywhere you see warm colors here, that's where the temperature has been increasing over the past 100 years or so on average. So we have this overall increase in temperature, but we're also experiencing high amounts of moisture. So this graphic shows you essentially how much moisture is in the air throughout the course of the summer for the past 5 years on average. This is a map that shows land surface temperature. So think of land surface temperature as walking over asphalt on a really, really hot day where there's no clouds, the sun is just beaming down on the pavement. You probably don't want to be outside barefoot on that pavement, right? The same goes for grass. You may want to walk on grass barefoot, because it doesn't absorb as much heat throughout the course of the day, but pavement, on the other hand, is really warm. So that's exactly what's showing on the screen here. You see the darker redder colors those are indicative of higher temperatures that are also associated with urban development. In downtown areas, we experience these warmer temperatures because that surface is absorbing a lot more heat throughout the course of the day and then letting it go at a faster rate at nighttime, or even sometimes a slower rate at nighttime. But then you have areas with more trees, the suburban areas, the urban residential areas, the farm areas, the rural farmland areas. They don't absorb as much heat throughout the course of the day, and for that reason, they're cooler. Now, there's also an equity component that plays into this. What you're looking at here is a federal housing security map, or a Homeland Security Administration map that shows essentially what segregation looked like in the 1930s. So technically, the name for this, we see these red blocks, is redlining. And you can see that in these redlined areas, that's likely where black and brown people were secluded to. And as a result, there was disinvestment in these areas. And as a result of that, there was less tree canopy, less heat resilient infrastructure built, and people experienced climate hazards differently in places that are redlined. So this is a redlining map of Miami, to be exact. And in the city of Miami, like I was showing you before, those areas that were relegated to, the black and brown populations because they were redlined, they experienced the warmer temperatures. Those warmer colors are indicative of higher land surface temperatures. And that has a lot to do with tree canopy. So on the right side, you're looking at census block group greenness. So a measure of how green these areas are. And again, that same region in Miami, you see that there's browner colors indicative of less tree canopy, less greenness, which would imply higher land surface temperatures. And that correlates strongly across these two maps. So all in all, Earth's weather and climate operates in a balance, right? And global warming is unfortunately changing and throwing off how we experience this balance, and it's resulting in climatic changes. Now, heat extremes or heat waves are a result of this, but also an increase in humid heat, which can last throughout the course of the daytime and the nighttime, are also increasing. Urban heat islands make this effect even worse. They intensify the heat, and they're warmer than the surrounding rural areas. And then in urban areas too, these socially vulnerable, marginalized populations are more exposed. So with that, I'm going to stop sharing my screen, and I'm going to pass it off to Dr. Holder.
Thank you, Nkosi. That was excellent. Thank you for the summary.